Hi guys, welcome back to the channel. Jag here. In today's class, we're going to continue with our maths and content with popular demand. We are going to move on to the topic of common factoring and do some more practice questions on it. So with that, let's get started. All right, so here we are. Okay, so I just put down common factoring. Okay, so what you're going to do here, so let's put example. Okay, and I'm going to look for a common factor. And when you do this, you're basically just looking for the greatest common factor. Okay, so let's try an example here. Okay, so say I have 14m plus 21n. If you look at these two numbers here, I'm going to take out a common factor. Okay, the greatest common factor. I see I can divide both of these numbers by 7. Okay, when you're doing the letters, I notice one has the letter M here and I have the letter N. Okay, these are not like terms or common factors. I cannot take it out. I'm just going to open up the brackets. Okay, then you're going to do 14 divided by 7, which is 2. And the M is still there because I did not take it outside the bracket. Does everyone see that? Plus, we're going to do 21 divided by 7, which is equal to 3. And I'm left with the n as well, okay? Because I didn't take the n outside the bracket. Now, say I want to actually check my answer here, and that's what we're going to do. Okay, so this is what we got. Okay, so I should have left a little bit room there, but that's all right. You're just going to open up the brackets here, okay? So I'm going to do 7 times 2m, 14m, and then 7 times 3, which is 21, okay, n. Oh, sorry, forgot the 21, okay? So you're just doing actually 7 times 3n, so 21n, which is equal to exactly what we started off with at the beginning, okay? I do have to remember the rules of the exponents that we did go through in grade 9, okay? And you can apply that in this case as well. Okay, so with that, let's go to another example here, okay? Let's try one more that's quite simple. So 5c plus 10d, okay? So just like this. So in this case, okay, I can see I can divide both of these numbers by 5. Okay, but again, the first term I see has c and the second term has d, which are not like terms, okay? So I'm just going to open up the bracket. And from this first term, 5 divided by 5 is equal to just 1. Okay, you don't need to write the 1. But I'm also left with c here. Okay, plus we're going to do 10 divided by 5, okay, which is equal to 2. And d, because I did not take the d outside the brackets. Does everyone see that? Okay, so this is actually a really simple example here. Okay, so with that, let's go to the next example. Okay, and we're going to try this question. So I'm going to write it here. Okay, and we're going to try to check for the more complex questions here. So let's try this. So 2h4 plus 6h3 minus 4h squared. Okay, so now if you're looking over here, okay, the common factor, or the greatest common factor in this case, I'm going to take out the 2 because I can divide each of these terms by 2. Then you're going to look at the variable that has the exponent here. I'm taking out the variable that has the smallest exponent, which is h2. Okay, so in this case, 2h2 is the greatest common factor. I'm going to open up my brackets, okay? And I see right here, because I took out h2, and this is h4. So we're going to do 4 minus 2, which is h2, and 2 divided by 2, which is equal to 1. So I'm just going to leave that the same. Let's go to the next term. Okay, the next term here is 6h cubed. We're doing 6 divided by 2, which is equal to 3. Okay, and for h, I'm doing 3 minus 2, which is h to the power of 1. Okay, so remember, you don't need to write the 1 there. Okay, it's just assumed it's 1 as an exponent. And the last term here is 4h squared. I'm doing negative 4 divided by 2, negative 2. Okay, and the h2 minus h2, which is equal to 0. So I'm just going to close the bracket because the h is actually gone. Okay. Does everyone see that? Are there any questions? Let's try the check for this. I'm going to write it just on the bottom here. Okay, and this is just so remember the rules for the exponents. Okay, so let's rewrite what we have as the answer. And what we're going to do is the distributive property to check our answer. Okay, so I'm doing 2h squared times h squared. 2h to the power of 4, because I'm doing 2 plus 2. Okay, then you're going to go to the next term. I'm doing 2h squared times 3h. So 2 times 3 is 6. Okay, this is h to the power of 2 plus h to the power of 1, h to the power of 3. All right. And then lastly, I'm going to do the 2h squared times negative 2. So 2 times negative 2, negative 4h squared. Does everyone see that? Okay. And again, I'm just comparing my two answers here, and they should be exactly the same in terms of what you started off with. Okay. Now say you did actually factor this out, okay, and you didn't take out the greatest common factor here. Okay, there's no need to worry. What you do is you're checking inside the brackets, and I'm just seeing if I have any like terms inside the brackets, okay? And if I do, you could just add an extra step and take out that factor, all right? Okay, with that, let's go to the next example here, okay? So let's write it on the bottom. Okay, so let's try this question. So it's a 16x cubed y plus 18x y cubed. Does everyone see that? Okay, we're going to take out the greatest common factor. Okay, so I'm looking for a number that I can divide both 16 and 18 by. Okay, so the greatest common factor does look like 2 here. Okay, so look very closely because we have two variables in this case. I have x cubed, and this is x to the power of 1, okay? So we're going to take out, basically, again, the smallest exponent. Here it's x to the power of 1. You can put the 1. Let's put the 1 for now. And if you look at y, this is y to the power of 1, y to the power of 3. So I want to just take out the y to the power of 1, okay, or just the y. So open up your bracket here, okay? We're going to do 16 divided by 2, which is 8. Okay, and then for x, this is x to the power of 3 minus x to the power of 1, so x squared. Okay, if you look at y here, I took the y outside. This is actually just y1, right? Let's put 1 here. This is 1 minus 1. Okay, y is equal to 0, so it's just gone. Plus, let's go to the second term. We're doing 18 divided by 2, so 9. Okay, look very closely when you do these questions. Make sure you don't rush, okay? This is x to the power of 1 minus x to the power of 1. X is gone, okay? And you're not going to include it inside the brackets here. So let's do the y. This is y to the power of 3 minus y to the power of 1, which is equal to y squared. Does everyone see that? Okay, let's try the check for this question. Okay, as you can see, we do have some exponents that we are dealing with here. So I'm just going to write down our answer that we got. Okay. And it's a good idea, okay, to check your answer if you do have time to do that on a quiz or a test. Okay, it should only take you like about 1 minute to do so. And do that so you can make sure your answer is correct. So we're going to do the distributive property here. Okay, I'm going to do 2 times 8, so 16. Okay. Now, if you look at the x value, this is x to the power of 1 plus x to the power of 2. So x power of 3, and then the y is power 1. Okay, and that's because there's no y in this first term here. So the y just stays the same. Okay, and then plus, I'm going to take my first term, times it by the second one here. Okay, so we're doing 2 times 9, 18 x1. Because I see there's no x term in here. But for y, it's going to be 1 plus 2. Y to the power of 3. Does everyone see that? So remember for the exponent rules, when you are multiplying, I have to add the exponents together. Okay, if you have the same base. Okay, so one more time, we're just looking at our check answer here. Okay, and then you're just comparing it to what we started off with, and I can see that it's exactly the same. So I know that my answer is correct. Okay, are there any questions there? Good. Okay, with that, let's try one last example. Okay, let's try one. Okay, we're taking out again a common factor. So let's try 15a4 b3 minus 10 a squared b5. Okay, so the questions we are doing here is from the Principles of Mathematics. This is actually the homework book, okay? And I do highly recommend you getting this. The homework book has so many different questions that you could be trying for practice if you did do the questions from the textbook. Okay, so let's take a look at this example. I have 15 and I have negative 10 here. So I can divide both of them by 5. Let's take the 5 outside. And this is a good example, okay? The a value here, the a exponent is 4. Here, the a exponent is 2. We're going to take out the a squared. Okay? So again, just take out the variable that has the smallest exponent. Okay, one more time. This is b to the power of 3, b to the power of 5. I want to take out b to the power of 3. And I'm going to open up my brackets. Okay? Whatever you take out as the greatest common factor, you're just taking this term now, and I'm dividing it by my common factor, or my greatest common factor. So 15 divided by 5, which is equal to 3. Okay, because I'm dividing here, I'm just subtracting these exponents. So for a, I'm doing 4 minus 2. So this is a squared. Okay, so look very closely. For b, I'm doing 3 minus 3. So the b is 0, and it's gone. So we're going to move to the second term here, okay? Negative 10 divided by 5 is negative 2. Okay, look at the exponents. For a, this is a2 minus a2, so the a variable is gone. For the b, I'm doing b5 minus b3, so this is b squared. So just like this. Does everyone see that? And lastly, let's try the check for this one. Okay, this is actually a really good example. And again, the teacher will most likely give you questions that are a little more complex. Okay, and remember, you can also have 3 terms. It doesn't just have to be 2 terms. Okay, and in that case, make sure you are looking for the greatest common factor involving all 3 terms. Okay, which is kind of like this example we did up here. Okay, but the teacher will give you more variables, okay, just to try and trick you. So this is our check, okay, that we are looking at here. So let's do the distributive property once more. We're going to do 5 times 3, 15. Okay, because we're multiplying, I'm going to add the exponents together. A squared plus a squared, this is a to the power of 4. And b3, because this first term doesn't have any b values. Everyone's good so far? So let's go to the next term here. I'm doing 5 times negative 2. Okay, take the sign in front there, okay, which is negative 10. Oh, let me make the arrow here, okay. And the same thing. So here I don't see any a values. So the a squared will stay the same, like that. And you're going to just add the b values together. This is b3 plus b2. So b to the power of 5. Does everyone see that? Okay, and that's all you're doing basically for common factoring, okay? What I did here, so again, just like make sure you have the exact same answer, which is here. And it's exactly equal to what we started off with, okay? So I know that my answer is correct, okay? So in common factoring, we're just taking out the greatest common factor. Okay, whatever factor you take out outside the brackets here, okay, make sure you're just dividing each of the terms. So I guess we should look over here. I'm taking out a greatest common factor. And each of these terms, I'm just dividing it by the greatest common factor. And for the exponents, for the variables, I'm just subtracting the exponents, okay, to make sure that I have simplified the whole expression. And remember, when you're actually factoring, okay, the expressions are exactly the same, okay? If I give you the value for a, for example, I say a is equal to 2 and b is equal to 3. Okay, and if you take these values and you substitute it into the original expression, okay, and then you substitute it into the factored expression, I should actually be getting the exact same answer, okay? And this is kind of like a communication question. The reason you get the same answer is because I'm not actually changing anything in the expression itself. Okay, I'm just factoring it out. And sometimes it's actually easier to sub it into the factored form. Okay, these values that are given. And that way you can evaluate the expression right away. Okay? All right, so that looks good. And if there are no questions, that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I will see everyone in the next video. Thanks. Bye.